So friends, welcome back to our channel. Today we have in our agenda to study about simple linear regression along with some applications in from the world of business. So the photograph that you are seeing in the screen is actually an example of a scatter plot where a straight line is fitted to the data with between two variables x and y. This is an important diagram, I will say, because we will take dive and we will study these concepts in more with more clarity and try to understand how these values of x and y from which we go and fit a line and how from data we reach to decisions. So over to the presentation, let's get started. So in this particular video, we will be covering the following few aspects. First, we'll review the correlation coefficient which we have studied in our previous video. And along with that, we will see what are the limitations of correlation coefficient. We'll try to introduce the simple linear regression equation and also try to understand the difference between correlation and regression. I mean to say that already we have seen that correlations helps us to understand the relationship between two variables. Then why shall we study regression? What are the added advantages that we have in regression over correlation? We will also try to understand how to calculate and interpret the values of the regression coefficients. We will try to figure out how the goodness of fit of the data, I mean to say how well the data fits the regression equation. That is also an important concern, and we will cover this in this presentation. We will also look at the Excel computation and then find out how this computation takes place in Excel, as in case of some of our previous presentation. And then we will see in this process how regression can be used for forecasting and decision making. So let us move forward. Now, uh, uh, how do we meet or how do we travel starting from correlation and go up to regression? Correlation actually tells us that what is the relationship between two variables. Is there any type of relationship? Is a variable x is influencing another variable y and vice versa? We can understand how strong their interdependence is, how they are connected to each other, how strong is their relationship. And also we understand the direction of the relationship. If you recall, there we have discussed earlier in our previous video on correlation about positive relationship, negative relationship, and independence. Positive relationship, let us take a review that if the variable x increases and y also increases, then it is an indication of a positive relationship. Vice versa is also a positive relation. That means x decreases, y also decreases. That is, those are two are examples of a positive relationship. In negative relationship, we have if x increases, then y decreases, and if x decreases, then y increases. That is, movement of the variables are completely in different direction. Then that is an example of a negative relationship. And when increase in x does not influence the increase or decrease of y, then we come to a situation where they are not connected to each other, and we call that they are uncorrelated. X and y are uncorrelated. But uncorrelated does not mean that they are independent. So these are the directions of relationship which you can study with the help of correlation coefficient. Now, regression answers some more points in addition to what correlation does. First is that it extracts the exact nature of the relationship. Nature of the relationship is generally studied through equations, linear, exponential, quadratic, etc. So, regression helps us to answer that question. But what is the nature of relationship between the variables? However, in this presentation, we will restrict our understanding or discussion only up to the extent of the linear relationship. Now, regression gives another vital answer that if x increases, that is, in regression, we generally speak of two variables, but we identify these two variables as one which influences the other variable. The one which is influenced, that is called as the dependent variable. and one which influences the dependent variable is called as the independent variable. Generally speaking, we take y as the dependent variable and x as the independent variable. This is by convention, but does not necessarily mean that this is always true. You can have the reverse also. You can make x the dependent variable and y is the independent variable. But if y is the dependent variable, x is the independent variable, then we can find out with the help of regression that if x changes by 1, that is unity. If x changes by unity, then what is the change of y? X changes by unity, then what is the change in the dependent variable y? That we can answer through regression. And also, most importantly, which correlation does not do, but is very important, is that we can use regression for the purpose of prediction. That means, suppose we have a value of x corresponding to which we do not have the value of y, then using correlation, using regression, we can find out that if x equal to such and such value, what is the corresponding value of y? This is called as prediction or forecasting. This correlation cannot do, and so that's the reason why regression is considered to be a step ahead of correlation. Now let us learn about simple linear regression, a statistical method that allows us to summarize and study the relationship between two continuous variables is called as a regression. In a regression, we have an independent variable, which is also called as the predictor or the explanatory variable, and we have a dependent variable y, which is called as the outcome variable or the response variable. And what we want to do? We want to predict the value of y for given value of x, or we want to find out that what is the change in y if there is a unit increase in x. So this is basically purpose of regression. Now, when I speak about regression, as you can see here, the model is y equal to a plus bx. So, first thing is that I have some data, and based on the data, I want to find out that what is the corresponding value of this, or how the model looks like this one. In this model, we are actually in search of A because the value of A we don't know, and B. These two values A and B are constant which are determined from the data. That means we have data which appears pairwise, values of X and corresponding values of Y. Based on this data, if we are thinking about or speaking about simple linear regression, we basically try to estimate the value of A and B, and these are called as the constants. Now we are to find out a straight line. This y equal to a plus bx. This is an equation of a straight line. We want to find a straight line which best fits our data point. Best fits. There may be many straight lines, but out of which one is the best fitted data points? Best fitted line that we want to find out. When I tell the best fitted line, I want to mean that I want to estimate the values of a and b, which is best representative of the relationship that xy enjoys in linear terms. Okay, so here we have y as the in this equation y equal to a plus bx. As you can see, what is the role? Let us try to understand the role of each of them. Let me get a little bit of, okay, let me delete this and get a clear picture. Okay, now let us understand in this model what are the aspects of this model. First, you see, we have here y. Y is the dependent variable. So that is what I want to predict. So y is the dependent variable. So, sorry, this y. Then we have x. X is the independent variable. That is the one whose value we want to, uh, which is actually our explanatory variable whose value is known to us, and we want to use the variable value x value to predict y. We want to have an intercept. So a is the intercept. It is a constant, as we know. Is the intercept. What is its role? It will give you the value of y when x is equal to 0. So what is the value of y when x equal to 0? That will be given by the intercept. And slope is the rate of change. That means when there is a unit change in x, what is the corresponding change in y? That is given by the slope, that is b. So these are the role of a, b and xy in the entire equation. Okay. Now, when I get these are some of the points. We have plotted say x and y values. So when I plot, I get some points like this. Now, I want a line of this form which passes through, which seems to be a very good fit because it is closest to all these values. There I may get another line. Someone may tell that, okay, this line better fits the data. But you see, some of the points are very far away from the line. So this will be rejected, but this is the line which is closest to all the points. Taking the distance of all the points together, this is actually closest or have the less minimum value in terms of distance of the line from all the points taken together. So that is the process by which we actually find out or establish the line, or in other words, find the value of A and B from data. This method is called as the method of least squares. Let us try to understand this step by step. Now, what are the data requirements and what is the method of least square? First thing is that we require the values of same information that we require, that we used in case of calculating the correlation coefficient. That means we have the set of values of x and y in pairs. So I have x1, y1. This is one pair of xy values. Then I have x2, y2, and then dot up to I have x and y. That means I have n such pairs of the values of x and values of y. After that, the goal is to find the best fitted points that we know, and then best line which fits all the points taken together. Okay. The method for that, a statistical method used for that, is called as the method of least square. Method of least square is the best fitted line that minimizes the sum of squares of vertical distances between the observed data points and the line itself. Let us have a diagram to understand this. What is the meaning of this sentence? Now let us look at this. Suppose this is the line, the blue one that you see, seeing the straight line, that is the fitted line. And these are the points, these all the red dots that are point. Now you are seeing a sky blue colored line. This is basically the distance. For example, this if you see this line, let me rub the other tick mark so that we can be very pinpointed in discussing. This is coming from the previous marks. Okay. Now have a look at this. Suppose let us assume this is one point. This is the fitted line. Blue one is the fitted line. This line, what? This line is the distance of the point. This line is the distance of the point from the straight line. So say this one. So what I want to say is this one is say D1. This distance is say D1. Now, since it is a distance, distance is a vector quantity. That means if it is above the line, if I take it positive, then this distance, say this distance is d2. You see, this d2 I have to take negative. So what I do is that because I have to, if I take d1 positive plus d2, d2 is minus, so minus will come up here. So ultimately these will cancel each other and the distance will decrease. So what I do that I take the square of all the terms, square of the distance. So say I take all the distances of the points from the straight line. So that I call as say L. L equal to this. So distance plus dot plus say n points are there, dn square. Now I want this distance to be minimum with respect to A and B. That means A and B are to be obtained in such a way that this distance L is minimum. That is the concept of the method of least squares. That means, suppose this is one line. Now, suppose I tell another line, no, let me take a red line. Okay, let me take a red line. Say, I tell that, oh, no, this is not the good line. This is a good line. Say, I tell this line is better. But say this is should be a line. I have means let me get a line. It looks more like a car, so it will make it difficult to understand. So let me place it like this. Suppose I have another line and the line is like this. Say the line is like this dotted line. Now I tell that this is a better fit. But actually you will find later on that this is better. Why? Because suppose this one distance is from the blue line is this. And distance of the points from this line that I have drawn just now, say this one, say this one. I tell that this is giving better fit because it is passing through several points as you can see here. So this distance is say L1 and my distance of the points from my line, that means this distance from the first point plus this distance, all these things, say I call it L2 equal to, say this one is giving del d1 d2. So in to differentiate, I am writing del 1 square plus del 2 square plus dot 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 plus del n square. Now this line will be discarded. My red line will be discarded because the value of L2 will be more than L1. I want to choose that line which has minimum value of the square of the distances. When I tell this line, that line, what I mean to say is that I try to estimate the value of A and B. Now, this line also have some value of A and some value of B. This line also has A, B. This line also has some value. This blue line, this also has some value of A and some value of B. This line also has. But then what I will do is that I will choose this particular line. When I choose this particular line, that means I will go with the value of A and B computed based on this line and not these values of A and B. This is what is the purpose of the method of least square. Now, what is the formula for that? Is there any simplified formula that, or I have to manually measure the distance? Let us see in the next step. So obviously, okay, let me remove these marks coming up. Okay, now what happens in this? Say, now there is obviously there is a formula. Now look at we have the formula for the slope and then the formula for the intercept. The formula for the slope is given by correlation multiplied by standard deviation of y divided by the standard deviation of x. So this is the correlation between r is the correlation between xy, and then we have sigma y by sigma x. So this is the slope. So this comes the slope, and the next one, that is the intercept. This is the slope. This is the slope, and next, that is the intercept. It is given by y bar minus bx. So this is, we have the intercept. So this way I find the value of B and this is the value of A. This formula of B and A are obtained using the method of least square. Now what is method of least square and how method of least square helped me to find B and A? This discussion we do not do right now because this is beyond the scope of what we are studying. So with the help of the method of least square, we reach to this formula. That means if you want to compute B, you have to be aware, or you have to compute the correlation between the variables. You have to calculate the standard deviation of x, you have to calculate the standard deviation of. Once you know all this, you can compute B. In addition to that, you also need to compute the value of x bar and y bar. However, as you know earlier, that when we want to calculate the correlation coefficient, we have to calculate x bar and y bar. So that way, for intercept, we don't have to compute anything additional. While computing the slope, whatever things we compute, that information as along with the value of B will be used to find the value of the intercept. So this is how this intercept concept can be computed. Now here we have directly one problem, and this is a similar type of problem that we have done while we dealt with correlation. But this time we have different agents. We need to find out the regression equation and we have to do some estimate also. Let us read the question. A marketing manager wants to predict the sales based on advertising expenditure. Use the data below to find the regression equation. Here X represent expenditure in advertisement in measured in $1,000 and Y is the revenue earned in $10,000. So this is the equation we have. Okay, these are the number of months. This is the expenditure on advertisement. This is measured in $1,000. Remember, here when we have 5, 8, 10, these are $5,000, $8,000 like this. And Y, that is the ultimate revenue that you are earning, that are in $10,000. So 6 means $60,000, 9 means $90,000, 10 means $100,000. So that point you have to keep in mind. Anyway, so that will be used later on. So first let us find the equation. So to find the equation, as we have seen in the previous slide, that we need to find the value of B and R. For B, we need to find the correlation coefficient. We need sigma x, sigma y. So let us do this. That is correlation. So first we do this table we have, and then from the table we actually go ahead. And then this is the formula for correlation. We are writing the formula because this will give us a guideline that what all things we require to compute. You see, you require to compute x bar. For x bar, you require summation x. We require y bar. So for that, I require summation y. Then I require summation xy. Then I require summation x square, and then summation y square. So first, we let us make the column. So you see, I have calculated summation x, sum of this column, that is 50. Then I have calculated summation y, that is 54. Okay. Then we have calculated x bar, summation xi by n, so this is equal to 10. Then we have y bar, summation y by n, that 54 by 5, that is 108. So we are, sorry, not 108, 10.8, 10.8. And then we compute these columns because otherwise I cannot calculate correlation. So xy, product of 5 into 6, 30. That means multiply x with y, corresponding elements. 8 into 9, 72. 10 into 10, 100, 12 into 13, 156, 15 into 16, 240. So this is I actually calculate the value of xy. Then I calculate the value of x square. That means 5 into 5, 25. 8 into 8, 64. 10 into 10, 100. 12 into 12, that is 144. And 15 into 15 is 225. So these things, square values, you may summarize up to the value of 15. This is very handy. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, like that. Up to 15 you summarize because they are often required. Now, y, just to take the square of y, 6 square is 36, 9 square is 81, 10 square is 100, 13 square is 169, and 16 square is 256. So, these we have computed. Now, you see, if you look at the formula of correlation, you will understand that we require the sum of these columns. Otherwise, I cannot get summation xy, I cannot get summation x square, I cannot get summation y square. So, here I go, I calculate the sum of these values. Now, x bar we have, y bar we have, and all the other summation values I have. Now I can use the formula of correlation coefficient. So here we go. Summation xi is 598. N is the number of observations or number of pairs. So that is 5. X bar is 10. Y bar is 18.8. And here we have summation x square, that is 558 minus 5 into x bar square. So x bar square is 100. And summation y square 642 minus 5 into this. So accordingly, I replace the values here. So this is equal to, we have these values, and then ultimately we get the correlation as plus 0.99. So correlation, till correlation we have computed, but you know that we have to go beyond. If you can recall this formula, you see just only we have done this correlation part I have done, only this part we have done. For B, I require to calculate sigma x and sigma y. Okay, so let us proceed. We have all these things already. Okay, now we come to this, just we continue this previous table as it is. We are just writing for maintaining a continuity. Otherwise, table you will write only once, definitely. X bar, y bar, and r we have computed, just we are writing it for to maintain the continuity. Okay, now we first calculate sigma x. So this is the formula of the standard deviation of x, 1 by n summation x square minus x bar square. So this is equal to 3.4. And then summation y equal to under root 1 by n summation y square minus y bar square equal to 1 extra is there, sorry. So this is equal to, and then we replace all these values, find that it is 3.43. So this is sigma x, sigma y, and then x bar, y bar, and r. Now we have calculate b. This is my byx or b, that is equal to r into sigma y by sigma x. So just I replace the value and find the value of b as 0.99. Now I will compute the value of a equal to y bar minus b into x bar. So y bar is 10.8 minus b 0.99. We get it here, and then we have x bar 10. So this is equal to, when we do this simplification, I get this 0.9. Now we have all the things of the equation. I know the value of a and b, and that is what I wanted. So ultimately your equation comes out to be, here is your a 0.9 and here is your b 0.99. Now you see there was a part of the question. That question I was asked to estimate the value. Here you see, here represent the expenditure at okay, so prediction of sales. Okay. Okay, we are not asked to predict that way. The manager wants to predict the sales. Use the data below to find the regression equation. Okay, I think I am done. So the regression equation is done. So the regression equation, this is just I am taking as a additional metal as a note, that how we can use the equation. What is the purpose of the equation and how I can use the equation for anything going forward. So moving forward, you see, first thing is that we understand that when x increases by unity, y increases by 0.99. Okay, this is an important finding. Now, suppose you want to estimate the ad expenditure is 20, then what will be the revenue generated? Now, here you put in place of x 20, when you multiply this is you get 20.7. So why is here 20.7? 20.7 what? 20.7, $10,000, because data was in $10,000. That is what I actually told you, that expenditure is in $1,000 and revenue earned is in $10,000. So whatever estimate we get at the end, you have to multiply it with $10,000. So this is $10,000. So you get actually $207. Sorry, $207,000. This would be the revenue earned by the organization. Okay, so this point is very important. Otherwise, if there is no concept like $1,000, $10,000, then just you put the value of x, and whatever be the value of y you get, that is the estimate. But here, since the concept is with respect to $10,000, so we multiply it by $10,000 to get the actual revenue in terms of dollars. Okay. Okay, now let us sum up. Okay, now let us sum up all these findings of the regression exercise that we had done just prior to this slide in a formal way, so that the advantages of doing regression are clear to us. First is that we get the equation. This equation is a mathematical relationship of x, that is in this case expenditure on advertisement, and y is the revenue generated. So we get this equation. This is the first advantage. We get the value of the intercept, which is 0.9. That means if we don't do any expenditure on advertisement, then also we get zero point 0.9 into $10,000. That means very close to $10,000. It will come up to $9,000. So $9,000 will be the revenue earned if you don't do any expenditure on advertisement. This is what the intercept is telling, and slope is telling that for additional $1,000 increase in advertisement, the sale will go up by 0.99 into $10,000. That means $9,900. That is the amount of revenue which will be generated for every additional 1,000 rupees expenditure. Sorry, $1,000 expenditure on advertisement. So if you spend $1,000 more in advertisement, your sale will go up by $9,900. So that is the plain, in a very layman's term, the use of the intercept and the slope. So this is what is written here. So you may take a screenshot of this if you want to understand it better. And finally, the slope gives us the marginal effect of the impact on sales. That means how much the slope influences sale. That means slope means how much the say expenditure on advertisement influences the sale. The intercept gives us the sale when there is no expenditure on advertisement. So that is what we have been discussing, and that is one very, I mean, this is the technical explanation of the regression equation. But because at the prima facie we just see an equation, but what are the information that is embedded in the equation, that you can get from these three paragraphs. We move forward to understand the strength of the fitted regression equation. Now, what is the strength? Concept of strength. Strength means for any data, if we feed any data through the computer or to calculate manually, we generally will get a fitted equation. That is the best fitted equation. So fine, means given all other possible types of line, the particular line that we get using this method gives us the, means more closer to the points than any other such straight line. But whether that particular straight line, which is the best one, gives us a reasonably good fit, means whether it will be able to predict the values of y given the value of x, that measure is called as the strength of the regression. So once the prediction is done, we also want to know that how nicely the equation fits to the data. The measures the proportion of variance in the dependent variable y that is the predictable form, the independent variable x. The square of the correlation can be used for this purpose. This is called as R square. The value of R square of the correlation coefficient lies between 0 and 1, because R, that is the correlation coefficient, starts from -1 goes up to +1. So when you take the square, there is no point of getting any negative value. So R square value lies between 0 and 1. Multiply the value of R square by 100. So if your R square is say 0.97, if you multiply it by 100, you will get 97%. What is the meaning of that percentage? That percentage is actually the value of or the amount of variation in the dependent variable that is explained by the independent variable. I want my independent variable to explain the variation of the dependent variable as much as high as it can. Obviously, the highest value will be 100%. That means all the values of y are correctly predicted. So this does not happen in reality, but we want to get some value close to 100% when we multiply r square by 100. For our example, we had r as 0.99, and when you take the square of r, that is r square, comes out to be 0.98. Multiply 0.98 by 100. You will get it as 98. So 98% of the variation in the dependent variable can be explained by the independent variable. So this is the purpose and how goodness of fit of a regression model is studied. Now, there are two lines of regression. At the beginning of a discussion, we told you that as per convention, y is taken as the dependent variable and x is taken as the independent variable. And also, I made a disclaimer that this is not always true. Sometimes you may take x also as the dependent variable and keep y as the independent variable. For example, rainfall and humidity. So you may have a relation in both ways. You can have humidity connected to rainfall, because humidity goes up high, then people tell that there will be rainfall. That means amount of rain might be connected to humidity also. And then if it rains, then humidity obviously increases. So both ways, someone can establish a relationship. That means x can be dependent on y and y can be dependent on x. So we can have actually two lines of regression since we have only two variables. So that is the way. First is that the one that we have been doing so far, y equal to a plus bx. This regression equation is called as an y on x equation. That means this equation, why it is called as y on x equation? So let me take white. I think that will be more visible. So this is a y on x equation. Y on x, because x is the independent variable, y is the dependent variable. So this is called as a y on x equation. Another equation, we have this is called as, we take x as the dependent variable and y as the independent variable. This is called as an x on y equation. Here we take x as the dependent variable, y as the independent variable. When we do this, the intercept and slope will change its values. It will not be same as the previous one. Okay, that's why we are differentiating it. One is I am writing a, another I am writing a1, 2. Express that the values will not be same. The equation will have different intercept and different slope. Now we have two lines of regression. As we know, we have discussed y on x and x on y. Technically, these are the equations. These we have already seen that, okay, y minus y bar equal to byx, x minus x bar. What is byx? Byx equal to r sigma y by sigma x. This is called as the y on x equation. That is what we deduced earlier, but in a different way. There the form was little bit different, but this is a simplified way of computing y on x, and y on x is expressed in this way. So y on x means y on y minus y bar in this side multiplied by this side equal to x minus x bar, but multiplied by a constant. And how to compute the constant, that we have shown here. So obviously you can see that we need r, we need sigma y, we need sigma x. This is same as the b that we saw earlier. Okay. And if we reverse this situation, it becomes x minus x bar bxy, because x is appearing first, so it is x here, y minus y bar. So bxy is expressed as r sigma x by sigma y. So you see r sigma y by sigma x, this is changed as r sigma x by sigma y. So this is equal to this way. So this is the equation. This is the x on y equation. So this is how actually we have these equations. You have to keep in mind when we go to further computation. Now we have a computation at hand. A plant manager is analyzing relationship between production volume unit and total cost. So this is production volume. It is in some unit of measurement, means number of counts, number of units produced, and the total cost is in dollars. Data for 6 batches is collected. The correlation R is equal to this. The value of sigma x is equal to this, and sigma y equal to 800. What is the mean volume? The mean volume of X is 200 and mean volume of Y is 2500 in dollars. So this everything is given to us, everything is computed. That means we don't have the raw data, rather we have those values which are required for the computation of the regression line. So we are asked to compute the line Y on X. We are to obtain the intercept and slope, and we are to predict the cost for a batch of 250 units. That means if 250 units are produced, what will be the cost? So let us get started with this. So first let us write all the things that we have, because in the question it is in a scattered fashion. So let me write it in a numerical form, so that everything remains before our eyes. R correlation coefficient 0.978, X bar 200, Y bar 2500. You can see here Y bar, this is your X bar, okay. This is your correlation coefficient, okay. Then we have sigma x equal to 50. So this is sigma x, and sigma y is equal to 800. Now, this is y minus y bar equal to byx, x minus x bar. So byx equal to r sigma y by sigma x. So this already we had get the definition. Now just replace the values, but before that calculate byx. So byx equal to r sigma y by sigma x. This we find that this value is 15.648. So that is the value of byx. Now we start replacing y minus y bar byx. So this is this x minus x bar. So this is this. Now we take this 2500 in the other side. 15.64 it gets multiplied with x to produce this. 15.648 into 648 into 200. That gives me this value. So ultimately when you do the computation, everything gives you this one. That means y equal to 15.648 x minus 629.6. So this is the equation of y on x. Now here is the intercept is this, slope is slope is this, that one which comes with x. It is the slope, and this is the intercept. So we get a negative intercept. So intercepts can be negative, means both intercept and the regression coefficient, that is bxy and byx, can go from minus infinity to infinity. There is no restriction like that of the correlation coefficient. So these are the intercept and slope. Now there is an estimate we have to make that for 250 units, what shall be the cost? So in this equation, that is the equation of y on x, we put the value in case of x 250. So this into 250 minus 629.6, 15.648, just in place of x you replace 250, and then you compute, you find that this is in terms of $1000. No, this is only in terms of dollars. Okay, total cost in dollars. So there is nothing like $1000. So whatever value we get, just we put a dollar before it. So to produce 250 units, my approximate expenditure or my estimated expenditure is $3282.4. That is the estimated value of the cost which is required for producing 250 units as per this computation. Now let us try to understand whether there is a relationship between correlation and a regression coefficient. Yes, there is a relationship. If you know, if you remember about geometric mean, you will find that the geometric mean of the regression coefficients is equal to the correlation coefficient. That means, in other words, the correlation coefficient is the product of the regression coefficient when a square root and then taking the square root of the two regression coefficient, that is regression of x on y and regression coefficient of y on x. That is the slope of the equation x on y and the slope of the equation y on x when multiplied together when multiplied with each other gives me the square of the correlation coefficient. Just take a root of that, so you get the actual value of the correlation coefficient. We also have to discuss, or we need to discuss little bit of the properties of the regression coefficient. First, regression coefficients actually can be zero. If the regression coefficients are zero, that means if bxy is zero, byx will also be equal to zero. So in that case, what happens? This means that there is no relationship between x and y. X and y cannot be expressed with the help of a relationship. Okay, both the means linear relationship at least will not be there. Okay, and both the regressions will have the same sign. That means both the regression will be either both positive or both of them will be negative. And if one of the regression coefficient is greater than 1, that means their absolute value is greater than 1, any of the regression coefficients, say xy, bxy is greater than 1, then byx will be less than 1. Oh, this is the relationship between the regression coefficients. So this is quite interesting. And one thing I just want to tell here, that for advanced learners, you may take a point here. This bxy and byx, both of them will be of the same sign. So this may be negative. If this is negative, then this is also negative. So the thing that will happen is that in that case, ultimately square root, because you cannot have square root of a negative thing, and they will become positive also naturally, because both are negative. So negative into negative multiplied, you will get a positive quantity. So the one under the root sign becomes positive, and if both of them are positive, always positive, that means correlation, this rxy will always give you a positive value. But we know that correlation can be negative also. So how we'll find a negative correlation if the regression coefficients product is always positive? The logic is like this. If the regression coefficients are negative, bxy is negative, then byx is negative, and in that case, though mathematically we'll get a positive correlation coefficient, but after getting the correlation coefficient, we'll put a negative sign over it, because these regression coefficients were originally negative. However, if both the regression coefficients are positive, then obviously correlation to always will get positive. But in that case, we will take the correlation as positive, because the regression coefficients both were positive, and the position of one positive another negative does not arise. So this is how you will extract the correlation from the regression coefficients. Remember this concept of finding out the sign of the correlation coefficient, because mathematically when you follow this equation, the equation in the left side, I mean this equation, sorry, this equation. In this equation, mathematically always correlation coefficient will be positive, but whether it is positive or negative, you have to look into these two steps. Okay, let us now proceed to the next one. Another example we have, you have some of the values, x bar, y bar, sigma x, sigma y, these things are not there, but the total of the columns, that is summation x, summation y. Let me take white. Okay, summation x, summation y, summation x square, summation y square, summation xy. These values are given to us. We are also given that there are n equal to 25. Now, you know that for regression equation, you need to find the correlation coefficient. You need to find the standard deviation x and standard deviation of y. So let us go by step by step. So this is the formula of correlation. This I write fast, because this will actually give you the overall picture, because the most of the things, the maximum requirement is in correlation so far as different computation is required. If you compute the correlation coefficient, with that information you can compute the standard deviation also. Okay, and then we have x bar. We have we compute this. We obviously have to get y bar also. So x bar is this, y bar is this. That information we require in the formula of correlation coefficient. So having known the formula of the correlation coefficient, we find out x bar and y bar. Why? Because summation x and summation y is given here, but x bar and y bar is not given. So divided by 25, because why? Because n is 25. Number of observations is 25 to get the value of x bar. Similarly, get the value of y bar. Then I put it here, and then we find out this value 508, 500, and then this is 25, and this is 60, and then this is 8, and then this is square root of 25 is 5, and square root of 6 is it will 7 point something. So we can use the calculator to find it out and then take the product. So ultimately we get the correlation as plus 0.21. Now to calculate the regression equation, We have to first find sigma x. So this is the formula of sigma x. And then we find the value of sigma y. So this is the value of sigma y. Now we have everything. We have x bar. We have y bar, which is required to compute the regression. We have sigma x. We have sigma y. We have r. With these values, we go to the next slide. Okay, so these are the 5 values which is required to calculate the regression equation of x on y and y on x. Now, regression equation of y on x, first we compute. So this is my formula. We have first to find out this. So this is byx, which I will be using here. This comes out to be 1.8312. Now we replace this value 1.8312 from here. This is this. And then we replace here 4 comes in this side. So it becomes positive. So ultimately we get the value as this. And then the value of x on y in the equation. This is the x bar. Then this value we replace here. Why we write 1? Because you see sigma x is equal to what? So we write this value here and we replace this value. We get the value of bxy, and then bxy we have this x minus x bar into 0. This is the bxy into y minus y bar. So we replace all these values here, and then we get the value of x equal to 0.0241y minus 4.9. So this is the equation of y on x. This is the equation of x on y. Now, one point is important. We have got the equations. We can do it. We have seen earlier also. Now also we have seen that we can find the regression equations of y on x and x on y. Suppose the question has a tech question that estimate y when estimate estimate y when x equal to 10. In that case, this equation also, and we can use this equation also. You will put 10 here when x equal to 10, when x equal to 10. We can put 10 here and do this, but don't do that. Go with the y on x. Since you are to estimate the value of y for a given value of x, so for that you use the y on x equation. Okay. And suppose I have that, okay, if y equal to 7.2, what is x? What is x? Now here you are to estimate x. What is known to is y. So use the x on y equation. So this is y on x equation. This is x on y equation. Using this, we find out the estimates. Okay. So this is one additional information which is not there in the presentation directly. Just I want to share with you. Now, let us see how we can use the Excel formula for computing the simple linear regression of y on x. We are just speaking about y on x. X on y will be automatically developed. Okay. Now, first we require intercept. We don't have a technique to get the equation directly. We have, we will see it also. But initially, when you go to base Excel, we don't have this. So we have to compute intercept separately. The formula is equal to, in any cell you write the equal to. Here you put the values of known values of y's. That means you just click and drag all the values of y's, and then the values of x. That means independent variables values will come later. Dependent variable will be coming first. So you have to remember this point. So generally we speak about x and then we tell about y, but in Excel the formula is designed in such a way that first it will take the value of the dependent variable and then it will take the value of the independent variable. So this is intercept, then we have slope. So slope is this. So once we know the value of the intercept and the slope, then we can find the equation of y on x. So these two information, intercept and slope, are sufficient for us to write the equation. X bar and y bar is required when you want to do the computation to find the intercept and slope. But here directly we can get the intercept and slope. Here also you remember that the dependent variables value will come first and then the value of the independent variable. Now earlier we have seen that R square is a measure which gives us an idea about the strength of the regression equation. So you get R square. The R square formula in Excel is equal to RSQ. SQ means square. RSQ, known y's and known x. That means this concept of using the dependent variable first and then the independent variable is common in all the three formula in Excel. So let us take an example. Suppose the value of the dependent variable is from in cell number A1 to A10, and the value of the independent variable is from cell B1 to B10. This is, we take the positions as an example. And then in case of intercept, I will use A1 colon A10, comma B1 colon B10. Remember one thing that Excel is not case sensitive. So A, B, etc. you can write in small letters also, doesn't matter. Then we have the slope. So formula for slope is A1 colon A10, B1 colon B10, and then R square will be RSQ within bracket A1 colon A10, comma B1 colon B10. So you have to be careful where is the position of your independent variables. Those cells will be referred later on. So we move into Excel to see how this computation is done. So over to Excel. In this Excel file, we can see that we have two variables. One is age and another is average speed. So age is actually the age of the driver, and speed is the average speed of the motorcycle measured in kilometer per hour. So these two information we have. We have to find out whether there is a what is the type of relationship that exists between speed as the dependent variable and age as the independent variable. So first let us see how we compute intercept, slope and R square, which is the strength of the relationship between the two variables. So we come here, we type in equal to and then we write intercept. Now, Excel is not case sensitive, so you may write in small letter, you may write in capital letter, or you may write in a mix of that. Okay. Now, as soon as I click, I press the starting bracket. Now, it tells us known wise. That means we have to put the value of the dependent variable. Here, age is the independent variable, speed is the dependent variable. So, we click here and go to the last value of speed. So, don't include the name of the variable because that is not your data, that is just information about the variable, only the data values. Then we press this comma and then we come and put the known x's, that means the values of the independent variable. So here it is. Remember one thing, that when we write this command, the number of observations for the known y's and the number of observation of the for the known x should be equal in number. Here they both of them are 12 and 12 each, and the values are available in pairs. So once we press this, then we get the intercept. So intercept comes out to be 67.35. You can approximate it by just adjusting this. So I can get the approximate up to two values for following the decimal point. You may have four values also. It's your call how much you want. Next we come to slope. So here we type in equal to SLOPE. This is the command for computation of the slope. Then we give the starting bracket. And then in the slope variable, once again, known y's will come first. That means these values of average speed, comma, and then the values of the average age, which is our independent variable. And then we close the bracket. So this gives me the slope of the regression. We can once again adjust the points after the decimal, so we get minus 0.66. Okay, and r square, that means the strength, so we write RSQ, RSQ, and then we start the bracket. Here known y's, so these are the y's, so this is same for all the three commands, and then the independent values of the independent variables. So we have this, and then we close the bracket and press and so this is the value of r square. So we have it around 0.53. That means if I multiply it by 100, so I get this as 53.53.02. That is approximately 53.02. That is approximately, let me increase the font size here. So 53.02%, that is approximately 53% of the variation in speed is explained by age. So that is how we get the different constants in connection to the simple regression between age and speed. With speed as the dependent variable. Okay, now if we want to see that there is another way of getting this equation also, complete equation. Here we have got the equation, but we have got the value of slope and intercept separately. But if you want to see the entire equation, then there is one option how we proceed is that we actually select the data from starting from the name of the variables. Then we go to insert, and in insert there is an option of charts. So we come here, we select the first one, so we get a scatter diagram. So if you look at the diagram, you find that as your this side in your x-axis you get the age of the individual, and y-axis you get the speed of the vehicle. So this you get here, and then this, then you come to plus, and then there is a trend line option. In trend line option, there is like more options. In trend line, you click here, then you get more options. If you come to more options, then you go down below, and there is one option like display equation in chart and display the R square value. So as soon as you display, you get the equation. Let me increase the font size so that we can see it better. So let us make it say 20. Okay, or 18. Okay, let us look at the equation. Now you see, you compare this with the intercept value and the slope. So intercept is 7.35. So you see it's 7.35. Here you may compare. It's giving 3 digits after decimal. So it is giving 67.349. But if you approximate it 2 points after decimal, you get 67.35. And then you come to this value minus 0.66. So x, this is the slope. You see minus 0.66. R square value 0.5302. You can see here 0.5302. So this is how we can see the entire equation together. And here this process can be used to get the intercept, slope and R square value separately. Now let us have a look at the difference between correlation and regression. So first is that the correlation actually measures the strength and a direction of the relationship between two variables, but regression builds a model with the help of which we can actually uh, understand about the direction of the relationship also, but then in addition to that we can also actually predict the value of y for given value of x. This is in correlation cannot be used for the purpose of prediction. But regression can be used for the purpose of prediction, and that is one of the reasons why regression gets an edge over the correlation coefficient. Uh, Correlations are unitless numbers, and correlation lies between -1 and +1. Regression equation is not unit free. It depends on the data, what type of regression, will be the unit of the regression equation. Also, it depends on which regression coefficient you are speaking about, whether you are speaking about the intercept or whether you are talking about the slope. And also, in addition to that, you need to know that whether we are speaking about the y on x equation and or on the x on y equation, because depending on the equation x on y and y on x, given that x and y have different units of measurement, the coefficients of the regression equation will have different units of measurement. So directly it is difficult to tell that these will be the unit of the regression coefficients. You have to look whether you are speaking about the intercept or about the slope, and also what is the type of line y on x and x on y. So this is little bit of a complicated issue. Correlation between two variables may be due to the presence of a third variable which is confounding. In the correlation example, correlation representation, we have seen about drowning and sale of ice cream as two variables which were influenced by the seasonal effect. So that was called as confounding, but nothing of that sort. Confounding actually exists in that way between the in case of the regression, or even if it exists, it cannot be identified directly. Okay, now let us look at some real world examples of how to use the outcome of regression to decision making or strategy formation. Marketing and sales, forecasting the sales based on pricing, expenditure on ad, or some economic indicators can be attained through regression modeling. This is just an way in which there are different. This is just an example of marketing where regression can be used, but there are maybe many other applications of regression in marketing as well. In finance, we can predict the company's stock. That is the risk involved. That is which we popularly stock market people call as beta. So we can use the regression to find the beta value, that is amount of risk which is involved in the stock of a particular company. In operations, it can use we can take the help of this to estimate regression to estimate the delivery time of a particular order. In HR, we can model relationship between training investment and employee performances. We can establish the relationship. We can see how employee performance may go up given the expenditure that we make on their training. In economics, it can be used to understand consumer demand based on their income. These are some examples in these fields. Not that in this field regression is restricted to the example that we are citing. There are so many other ways. This is just to give you one view or a bird's eye view or a simple example in that area where regression is used. Uh, so what are the main takeaways from the presentation? First is that we try to understand the simple linear regression involving one independent variable and one dependent variable. Then we found out that how we can form a model of the form y equal to a plus bx. We went a step forward and found out that how slope, that is b, actually quantifies the marginal effect of x on y. And then we have the intercept concept, that how intercept is used to predict the value of y when the value of x is 0. That means we understand the concept of the slope and the intercept. We understand how r square can be used to understand the strength of the regression equation. That means how good the regression equation fits the data, or how much reliable our prediction will be if we use the equation for the purpose of prediction. And then the correlation coefficient and the regression, how they are connected, we had seen with the help of some examples. Later on we saw how excels can be used, Microsoft Excel can be used to do the calculations related to regression. I think all of you had a very lengthy session in this video. Thank you for watching.